Today I'm going to be talking about some work that I've been conducting for my master's thesis at Boston College, using cellular seismology to study the Pacific Northwest earthquake catalog. So what is cellular seismology? It's a statistical method developed by Alan Kafka to test the assumption that past earthquakes can tell us areas where future earthquakes are more likely to occur. In order to do that, we would take an earthquake catalog of an area of interest and basically split it in half and assign it to pre or post catalog. Once you've done that, you would map the pre-catalog to the study area and then draw circles around each earthquake event such that the combined total area of the circles equals a given percentage of the study area. We often use 33% as an example, and that's what I'll be doing here. Once you've done that, you would then also map the post-catalog events as dots, shown here in red. And if that dot falls into the area where the pre-catalog circle is, you'd consider that a hit. The percentage of hits is how we talk about a given study area's correlation of pre- and post-catalog events, spatial correlation specifically. You can constrain the pre- and post-catalogs in a few different ways, the most common being time spans and magnitudes. The pre-catalog tends to be older, smaller earthquakes, and the post-catalog, newer, larger earthquakes. But you can also do it with depth, which I'll be talking about later. So just to give you some quick background information on the region that I'll be talking about, it's a pretty complex tectonic setting with a subducting slab that's currently locked and many crustal faults that crisscross the region near major metropolitan areas. Because of that, the seismic hazards in that area are actually pretty substantial. And that's a major motivation of why I wanted to look at here specifically, because the more you know about seismic characteristics, the better prepared you can be for any earthquake activity. So one other thing that I just need to mention before we get into the study itself is that there is this newly discovered kind of seismic activity in the Pacific Northwest known as episodic tremor and slip events, or ETS for short. We won't be talking about these events themselves all that much, but the area above where they occur on the subduction slab, so that surface projection of that, is an area of interest for me, and so I outline that as a particular targeted zone to look at. So speaking of the study areas, first the regional area is outlined right here and goes from the Cascades over to the coastline and just encompasses most of Washington state with a little bit of Canada up in here and just a teeny bit of Oregon down here. Additionally, I zoomed into that ETS zone that I just talked about, and it's outlined right here, the current version of it. There was an earlier version where I looked at a much smaller patch of the ETS zone, and that's actually the results from that is what is in the abstract, but I've since then broadened it to more area both north and south of that original patch and have based it off of this image down here. So we're going to talk about those results today. So the questions that I looked at while looking at this catalog and kind of the investigations that I started to get into is, first of all, just reevaluating the region as a whole. This has been done by previous CS studies, but as is kind of always the case, more data means more information. And so I reran that analysis with the brand new seismic catalog or earthquake catalog and just reevaluated it to see if the numbers have changed over the years. I then constrained the study area to that ETS zone and also conducted quite a few runs to see what the hit count for that overall would be and compared it to the regional values. And then I've done some preliminary runs on how the depth may change the CS hit percent, whether it be shallow earthquakes or deep earthquakes. And then also, we normally only constrain the pre and post catalogs with minimum magnitudes, but I wanted to also impose a maximum magnitude on the pre-catalog and see how that might change the hit percents that you see for both the region and ETS zone. So here are some results for the regional and ETS zones for all depths. And above is an example of each run that I conducted. And below is a histogram summarizing all of the runs. So one thing to take note when you're looking at this map, the green dots are now the pre-catalog data points, and the post-catalog are now represented by black circles, unlike the first version of CS that you saw earlier on in the talk. So then the results. Overall, the Pacific Northwest region had a 68 to 78% hit range, and the ETS zone had a 60 to 78% hit range, which I found actually pretty interesting because I expected ETS to have a higher rate given that it has the seismic activity occurring right underneath it. But apparently, as of right now, that seems to not be the case. So it looks like further investigation is needed as far as that goes. Then next, I did some preliminary runs on how the deep earthquakes, how many hit percentages they have, and versus the shallow earthquakes. And it turns out that the deep earthquakes have a lower hit percent than the shallow earthquakes, which is exactly the opposite of what I was expecting to find. So I'm really looking forward to being able to do more runs to see if that still holds true, because based off of previous CS studies, I would have expected them to be opposite given the setting, the tectonic setting, but more investigation needed, which is always fun when you're doing a kind of exploratory research. So then comparing the pre-catalog with a maximum imposed on it versus the only minimum imposed pre-catalog, there does seem to be an effect on the hit percent overall. You go from 73 to 71 and from 76 to 75. So it's a pretty small variation, but it does seem to have a higher order effect. And I will definitely want to do some more runs to confirm that that's an overall effect that we see between capping it and not capping it. So then I just want to compare the results that we got from the Pacific Northwest region, this new updated data, and the ETS zone with previous studies of CS done with intraplate regions and plate boundary regions. And interestingly enough, they both fall into both regions. And one thing that kind of is noteworthy is that it's at the lower end of the plate boundary region and the mid-range for the intraplate, which is odd considering it is a plate boundary, but I think that just speaks to how complex the setting actually is in the Northwest. And I look forward to kind of investigating that more, because that was not necessarily something you would expect to see given the fact that it is a plate boundary. So then just to kind of summarize everything that I've been talking about, the regional hit count was again between 76 and 78%, and the ETS area hit count was between 74 and 76%, which fell into both the intraplate and the plate boundary region ranges, but more so in the intraplate region, which is interesting and will require some further study. The preliminary results for the deep earthquakes for both the regional and ETS areas were that the deep earthquakes have a smaller hit count, whereas the shallow earthquakes have a much greater one, which is interesting and opposite of what I expected. And then also instituting a maximum on the pre-catalog lowers the hit count slightly, but it's probably a higher order effect. Some things that I want to continue on as I do this study and go into my master's more is just running more tests to make sure that these results are actually indicative of the area as a whole. I'd like to be able to test the ETS catalog using this method and see if it has any relationship with the seismicity that we see in the, or the earthquakes that we see in the area. I'd like to zoom in on some smaller regions within the ETS zone and the region as a whole and see if we get any different hit counts on that, and if that might correspond to any known crustal faults in the area, and give us any insight into the reoccurrence on that.